Hello, welcome to today's episode of Bobby Codes. This is the Exercism dev stream. Wow, like we did this one yesterday about the test runner, and I accidentally streamed for 7 hours, and after the 5th hour, let's say about halfway through, I was so lost. I had basically given up, but that was okay because we're doing a live stream. So since I'm documenting everything I'm doing, that means that someone could pop in or someone could watch it after the fact, and I figured that's how it would happen. But I ended up struggling for 2 or 3 more hours until it actually worked. So maybe that means that the thing to do is to just keep streaming until I end up with something. We actually exceeded the expectation of submitting a PR, and it was. I thought we were going to maybe go back to JavaScript from there, because that would be enough Exercism dev stream for a little while. But then we launched the representation UI at Exercism, which was the topic of yesterday's meeting, which was right after yesterday's stream, and I still haven't slept. Okay, so now that that's out there, we will. I'll show you what we saw on the call, which is the reason why I'm doing this, because this is just so exciting. The representation UI was just unlocked for a select few. We're calling them super mentors, people who are granted special privileges, since we know that they give advice that we trust. And there was a cutoff for it. To be a super mentor, you have to have a 95% approval rating, and on 100 or more solutions. And I was like, oh no, I wasn't sure if I had mentored 100 solutions, but it turns out I have, and I have a 100% approval rating. All right, so yeah, it's in the mentoring tab, I believe. Yeah, we have automation. And yeah, I have 152 solutions mentored, 100% satisfaction. And yeah, so this is our super special feedback automation prototype. And oh, how sad. What is this? Oh, I don't get to join in any of the... Wait a minute. Oh, you're not seeing the... I don't have to apologize because nobody saw that. I need to show you the browser. Okay. All right, so yeah, this is the new representation UI. It's in the mentoring section under automation. It's unlocked if you are a super mentor. And yeah, oh, how sad. clojure is not here. And, you know, I thought that we had launched the clojure representer, but no, since apparently we have not. Or there's somewhere else maybe where we need to flip a switch in some configuration or something. We'll find out. And I know I didn't get very far with the representer in any case. So we'll go over to the repository now. And it's in the Exercism clojure team. And the clojure representer. Okay, so let's open this in GitHub Desktop. And let's see. I need to put this on my screen like that. Cool. And okay, so this is the Exercism clojure representer. And let's open it in VS Code. How about that? Okay, so yeah, I was working on this a little bit yesterday after the meeting, seeing if I could hack something together. And I came up with something, but first, let's see, I want to
I don't ever expect to see anyone here on Saturday.
yeah, it's just the crazy ones, I guess, that want to work every day.
Well, I had some fun this week, so kind of making up for it.
Cool. Gesundheit. Okay, so we're going to move over into the conference room. We'll take a short break. Coming up. All right, now let's see if this. All right. Okay, now this is this one. Check, check. Mic test. Okay, cool. So, wow. Okay, so I just relocated. And for some reason this monitor didn't turn on. Alright, well, we'll be able to roll with this. Check, check, check. Yep, that should be good. Now that I'm used to using two monitors, it's essential. Friends don't let friends stream with less than two monitors. But this screen is way out of the way. Here we go. Alright, now there's going to be a bunch of tangly wires, and here's a smooth move just like this. Good enough. Except I managed to disconnect the monitor doing that. All right, there we go. And why does this not, okay, this is weird. That was indeed weird. Alright, so here is the Clojure representer project opened in VS Code. And the original version that I had hacked together was, well, yeah, it was not this, actually. So we'll go to the repo here to show the one that we made using tools-analyzer. And yeah, so actually I'm gonna select this text here and paste it into my editor. And we'll see we'll see if this starts up. It probably should with deps eden, yeah, which supplies the dependencies for actually what we need is the tools analyzer. Let's see where that comes from. Does that need a yeah, Clojure tools analyzer? That is oh yeah, it is here. That's a tools analyzer JVM. So yeah, why are we using tools analyzer? Well, what is tools analyzer? It's a code analyzer, which is analysis is what you would do after parsing, I guess, where you would take this gigantic data structure and then well, the analysis is explaining every last bit of it, including the environment that it executes in. I think that's what analysis is. So yeah, if I try to start a REPL, using deps.edn, using no alias. So Tools Analyzer is a great piece of software that's part of Clojure. It's not in Clojure core, but it's an official part of the umbrella of Clojure tools. And you know what? I'm having trouble explaining it, so let's go check it out. I naturally wanted to take a look at this to see how it could come in handy for the clojure, the Exercism clojure track analyzer. So it produces an AST. And since we're using the one on the JVM, let's go to that specific repo. And it warns us that that the AST is going to be not for the faint of heart. And yeah, so it warns you here that don't try to even read it all at once. Instead, you just print out small sections and look at pieces of it. And okay, so here's an example form, which is just this require expression. And this is the AST that is produced by the analyzer. It shows that we have an op, which is, I don't know what that means actually. Oh, it's requiring the analyzer. This is just analyzing the number 1. So it's an op, which is a const. And as an environment, in other words, the expression is in a context with its own local variables and its own namespace. Form 1, top level true. The value is 1. It's a type number. It is a literal with the ID of 0. And there's a couple of tags here. Alright. Now, to get a clojure form out of an AST, use the emit form pass. So what happened here? We just took the result of calling the analyzer on this let form here, and then called emit form on it, and it just output a clojure form. However, there's a star there. Why? Note that the output will be fully macro expanded. You can also get a hygienic form back using emit hygienic form. I think that means that, yeah, it has these special variable names that won't clobber others. As you can see, the local names are renamed to resolve shadowing. Alright, so I think we're going to actually, since I didn't know about that hygienic form thing, that actually might be what we want to use here. Except that I don't think I actually want to use this, but it might actually be, I want to show this because it was my first idea of getting a representer that's working, and it still might be the quickest path to getting one shipped. So yeah, since the analyzer just happens to come with this emit form function that gives us a normalized version. It's normalized and macro expanded. These are the whoa. What I wanted was the API docs. That's what I thought I was going to be looking at. Analyze eval. Where was where's the emit form stuff? Let's see. Interesting. Looks like this might be incomplete. Locals. Oh, there we go. It's interesting. I was just going back here because I thought I remembered that it said that it emitted a normalized form. And I'm gonna have to check to see if I'm remembering this right. Let's see. There were some changes to the README. All right. Well, I know I didn't look at it before this. could have sworn I saw it, that it said that it was normalized. So, yeah, you'll just have to take my word for it, I guess. That's, because it's taking the AST and then using that. So that was when I realized that we could actually, it would be a super simple, actually kind of cheating way to hack together a working representer using clojure.tools.analyzer. So first let's see if it actually works. I have done this before. Okay, so now it's loading everything. And here's a function that will let us get one of the example twofers that are over here in the resources directory. And we would just do that like this. 2 for 1. And we get the zipper data structure for the first example twofer, which if we wanted to then convert back into a clojure S expression. Okay, well now that's interesting. We could do it actually just with this. Z is rewrite-clj.zip, and there's a function called S expression, which converts a rewrite-clj node into a and so that normalizes it as well. Except no. It's not taking like an AST that represents. See, the result of the analysis is a much more involved, thorough process of breaking down what the code is doing. I think once it goes through the analysis, it's pretty much completely separated from its original source code format. I could be wrong, but anyway, so here is, well, that's a function that I wrote just that will just grab the actual twofer definition, the function definition. And yeah, actually that kind of makes sense, at least for now. So yeah, using this extract implementation, it'll just be grabbing their function, which is, well, for this problem, for demonstrating it at least, it'll be good enough. So then we have defined the represent function, and then we would call it here to get a representation for the first twofer. And so this is how it is normalized. Well, first of all, let's actually show it. Twofers 1. Yeah, so this solution is, well, it seems like that's pretty much the standard solution. That is, once these comments are removed, So that I don't actually want to use this extract implementation because we want to be representing. For this exercise, it would be fine because there would just be no one would ever use more than one function or variable definition for the twofer exercise, at least not that I would imagine. But for other exercises, they would. So instead of that, let's do something else. Okay, so let's see. This is expecting a node, a rewrite-clj node. So actually, what we want are, okay, let's take a look at the representer spec to refresh ourselves on how it actually works. Let's see, where is that? Would be because the way that it's going to work we're normalizing normalization and creating content about source code normalization. The representer interface. So what we need is, like we did in the Clojure test runner repo, we have a Docker file and a run script. Now the run script just takes an exercise slug and two directories for input and output. So that's what we want our function here to take. So let's say for the purpose here we have an in directory. And this will be set to the second of the command line args. But I'm not going to worry about that yet. Put a pin in that. And instead, we're going to take an example twofer solution here. And I'll copy the path of the directory. And just define that there. It didn't like that. What's going on? Yeah, I think this path is. Yeah, we need to change these to. Alright, so now the in directory is set. And we're going to get rid of this. And we're going to use this z of file, and it will be the in directory. Okay, we need to create a path. Let's see how to do that the right way, which would be in the Clojure test runner that we were just working on. This is great because we can reuse a lot of stuff from here. It's in the yeah, run exercise tests. So we were using Babashka FS here. Actually, what we're going to need is clojure FS. You know, so I'm not gonna bother with that now. I'm just gonna make the path this way, so we could just concatenate strings with the in directory. And it will be okay. What is the yeah, it's just called toofer.clj. Okay, so let's see if that works. And no, it doesn't, because apparently I didn't define that. There we go. Okay, so now we have our zipper data structure. Well, actually, we need to define it as something. It's implementation. And, well, you know, we're using this analyze function and passing it a string, but we have I'm pretty sure there was a function that will just let us pass it a file. Is that too much to ask? Can we parse import? Oh, I thought I saw something in there. Let's go take a look. I think we actually want to use this to analyze a whole namespace. Behaves like, what does analyze eval? Let's see. Evaluates the form after its analysis. Yeah, we don't actually want that. thought I saw a function that would parse a file. Oh well, so I guess we won't worry about that. But basically, the gist of what I was thinking is that we don't need to be using rewrite-clj, because we would be turning it back into a string at this point anyway. So what we actually just want is to slurp it. Yeah, excellent. Yep, that's all we needed. Okay, so now that's saved as implementation, and it's just the actual source code. And okay, so now let's try analyzing that. Yeah, actually, first let's take a look at the actual wow, I was really expecting it to be longer than that. Wow. That's not a terrible thing to look at all. Yeah, so this is the analysis of this. It's a string. That's a namespace. That's the file it's in. And that's the form. You know, we actually need to not pass it a string. Yeah. So we'll use Eden read string. So that would be, oh yeah, clojure.tools.analyzer. And so that's already required. And so we'll just say so what this will do is make it not a string, except it's not giving us the whole file. Let's see. Reads one object from the string. Well, I guess we'll just have to map. How is it said that analyze can take a vector, right? You know, we could just use the analyze ns function. But then how do we get it? Let's take a look at these docs.
So this just takes a namespace. So what we could do is just require the file, or load the file like this with load file. And the file will be this. And then we would just say analyze ns twofer. That might do the trick. No? Let's see. Maybe it needs to be quoted. Let's see how that's supposed to be used. So this should, seems like that should be working with the quoted namespace name. Since we indeed required the it could be maybe there's a problem with that. I think I forgot how this is supposed to work. Oh, maybe that did it. No. Let's see. Can't find twofer in class path. Yeah, why would that be? Because it's in the resources, which is not on the class path. So we would need to add it to the class path. This is getting too confusing. Let's see how else we could do this. We can, let's see. Let's look at some more analysis examples. It seems like that should work fine. So what is the problem here? Let's see. Why is... With Babashka, we have the class path namespace. So how do we just add a directory to Clojure's class path? It's just called add. Let's see. That's if it's deprecated, then what are we? What are we supposed to use? Let's see. Add class path, and that's a path, right? Let's see, what's the problem here? Yeah, it can be... okay, yeah, that's not a... well, it's a string object. If we... let's see. Yeah, if we added it to the source path, I was thinking that would work. In the deps Eden file. So this is the configuration that defines where the how the class path lookup strategy works. And it's in paths. Okay, so we are indeed looking in resources. So why isn't it finding it there? Let's try... resources slash twofers. And we'll just do /1 just for a test, I guess. Alright, let's see. If I kill this REPL, and start a new one, Okay, so we should be able to just require it because it's on the class path, right? And I think it just works like that. Ah, cool. So it did. All right. Well, I'm glad that that wasn't wasted time. Okay, so here's the analysis of that file. And now we can see it is a much larger data structure because it contains the analysis for every form. Okay, so then we'll use this, and you know what? Let's do emit hygienic form because we want it to have the hygienic variable names. The thing is well, we will have the class. We'll have the exercise that is loaded will be listed in the source path, so that makes sense. Let's just take a look at the normalized form that we get back. Oh, we didn't. We're doing. That's interesting. Huh. Yeah, why is this illegal arguments? Why wouldn't that be working? Let's try this again. Okay, it gives us the it's probably because we're analyzing an entire namespace. So if we take this here and just I'll do this in the comment form just so that it's clear that we're just screwing around. And first, let's see how many there are. There's 2. Because there were 2 forms in the code, the namespace and the function itself. Cool. So if we just wanted, we actually want to just throw out the namespace declaration because that's not going to be relevant for our representation. So we would just use the rest function. No. We want to just return the second one. Now let's try just evaluating this, and cool. So here we have our returned normalized hygienic form. So this might actually be a workable representer just the way this is. Which I kind of feel like making a decision now. it might be because if we want to start playing with this as soon as possible, it would make sense to take this and run with it, wouldn't it? So this represent function is currently nonsense. It's taking an argument that we're not using. So to make this a real function, we need to have this be executed by the run script, which means we just need a main function. And it takes a slug, an in directory, and an out directory. Alright, so now it won't care. Oh no, actually, we need to turn this into a symbol. Let's see. Because yeah, the slug is a string and it's not a namespace. It could be we just need quote slug. Let's see. Yeah, we need to. Yeah, of course that's not going to work. Let's just try. I'll just compile it and see if it works. And the slug it'll be passed as a string. Yeah, we needed to include a couple of directories, and yeah, we'll just do slash and slash because it doesn't matter. Oh, and yeah, so it works. The namespace can be a string. All right. I'll get rid of this comment block and get rid of this. Yeah, we can get rid of this. And yeah, we could basically check this in as the, and we would get rid of all of these. Alright, so I saved that file, and yeah, so this is the simplest possible representer. Let's take a look at the spec real quick, just to see if I missed anything important. Yeah, we needed to output a text file. And we need a mapping JSON file. Okay, so yeah, we have some work to do. Okay, yeah, the mapping, that's what lets us keep track of the placeholder variables. I need to go get my battery pack. Hold on. So cool. Cool. So what the main function currently returns a form, and so then we would use spit, and we need to call it representation.txt. Now let's see if it is smart enough to do that. Oh yeah, we needed to give it some things. And I think I saw something jump. Yeah, so now we have the representation here. And let's see, we're going to want to format it. The pretty printer should be enough, actually. If we just do clojure.prettyprint/prettyprint. Oh, interesting. Oh, it pretty printed it, but okay, that's not how pretty print works. How do we pretty print a file? I think I got into this mess once before. Maybe we just won't worry about that right now. We also have the zprint. I downloaded the zprint Linux binary, which is one of the standard Clojure formatting tools. So we could actually just call that. How do we preprint to a file? Now I wonder. Pretty spit. I don't know if I remember using this. Okay. Yeah, it just without string turns what would normally be printed into an output. So yeah, I like it. Let's just take that. And we're going to need a couple of things here. clojure.edn. That's for the read string part. Actually, we might not need that. Yeah, indeed we don't. So let's just do clojure.prettyprint as pp. Pretty spit. And then we would redefine this, and now let's try it. We got nil. Why did we get nil? Yeah, I guess we needed to use this part. Or, okay, let me see here. Then he tells us that it doesn't work. That is hilarious. If we just use without str, will that work? Let's try that. Back to normal spit. And we pretty print this using without stir. Cool. Why is it not showing? I wonder how long I was not showing the right thing. Well, at least nobody saw that. All right. So we're now writing the representation text file, but we need to actually spit it out in the proper directory. That should be good enough, I think. And then for the in directory, let's give it a real directory. And yeah, I don't like that. But here's where it would be better to use the file system path utility library. And we will actually, when we wrap this up, Alright, so now it puts it in the right place. oh, this should be out directory. And we're currently not using in directory. Because we're taking it for granted that one example implementation is on the class path, and as long as the solution is on the class path, then that should work, right? You know, actually it might not. Let me kill this REPL and start a new one, because I just realized that it isn't going to work without actually requiring it. And here I'm going to prove that. Okay, it's loading the analyzer. And yeah, we can see it failed because the path is invalid. It's only missing a trailing slash. Oh, I stand corrected. And let's see if this is the problem. So we would require. Oh wow, that was the require twofer. Oh, interesting. The specified path is invalid. You know, it's probably this path that's invalid. Wait. Yeah, that is it. That is going to be invalid with this trailing slash. And apparently without it as well. Okay, let's see what's going on. Let's see if we can just run this. Huh. We can. All right. That is the path that we just gave it. And yeah, you know, that should be fine. I don't know what the problem is. I'll just extract the body of the function here. To show that it works if we replace the slug with the slug. And it does. Okay, so yeah, so what's going on? There's a double slash here. Oh, because that's the this is for the in directory. Okay. Cool, that makes sense. So if we just switch it. There we go. And now we no longer know if that worked because of the require or not. So what I need to actually do now is kill this again and start a new one. Well, we didn't get an error. Let's see. And yeah, okay. I guess that's all we had to do. So I'll clean this up. And alright, so this seems like it'll be good to run with. I can delete that, and let's see, I guess the run script. Okay, so there's a run.sh here already. Alright, so yeah, this is what I did before. This might be it might be exactly what we need. Let's try running it. What I actually need to do is open it up in WSL and try running it. But, you know, I just noticed that we might have that here. Let's see. Just instead of... wait. Instead of PowerShell, I think I can just select Ubuntu. That's cool if that works. It stops me from having to load the whole thing. Wow. Okay, so let's just try, see what happens if we go run this. And we need to run it by supplying the arguments. So it'll be twofer and the in directory will be the one that is in the depth Eden file currently. Resources twofers 1. And actually that's not correct. Am I allowed to copy that? Cool. So the in directory is that / resources / 1 no slash yeah 1 / twofer no where is the resources / twofers / 1. And the out directory will just be resources. And that's interesting. Bad interpreter, no bin bash. I guess we'll have to actually try this in bash. Okay. All right, so we have we don't have the repo here yet, so let's get it. And all right, now I'm going to copy this file. And then I'll paste that in here. Save it. And, oh, we want to get rid of this anyway. I'll comment it out. Cool. Now I'll just open my regular terminal and we'll try it's there. Why wouldn't it? Is it not executable? Oh, that would be weird. That might actually be the problem. All right, now we need to supply it the proper args. So where was it that? Okay, let's see if this works. Cool, looks like it is. Oh look, there's a bug. Can't find find twofer okay, that makes sense because we didn't add it to the class path. Alright, so it's because the indirectory was I guess let's just try, let's see, why did, when it said creating representation, that was from the run script that did that. So this is the one that formatted the path incorrectly. Yeah, output folder. Well, it's just expecting the output folder to have a trailing slash, which, yeah, I guess we should have done that anyway. But the actual problem is that we need to add it to the class path. So will that work if we do that? Now it doesn't like the linter doesn't like it. Oh, that's what the linter is telling us, that it's deprecated. So what are we supposed to do? What are we supposed to use with that? A library? Or let's check out this link that they're so kind to provide us. Let's just see if this works, I guess. Oh, there's an error right there. Oh, it's complaining that add class path is deprecated. Okay, let me think. We shouldn't actually have to do that because we could assume that the indirectory is already on the class path. And we will add that for the resource path according to, well, wherever the indirectory is when it's called. So let's look at the run script to find that. Well, actually, it's passed there. It would be in the Docker file, I guess. That's the working directory. And, oh wow. I guess I'm glad I saw that. /opt representer. So that's how we would get it working in production. So before this would work, we would need to add opt to there. But since right now we're just testing it in development, let's just put it in the resources directory. So what I'll do is just take our twofer and just paste it in here. And now we could run this again. Oh, yeah, it's we need to take out where we're calling the deprecated function. Interesting that it actually makes the whole source code, it makes the whole thing exit with an error. Alright, cool, so it works. Now the thing is this this doesn't actually normalize the variable names. They're given unique placeholder names, but that's because the variable was called name, and so it's just adding something to make it hygienic. So that means that we would still have to have our variables swapped out by some other way. Let's see. Yeah, that's an interesting little snag there for getting this working. And the reason I'm hesitating now is because this isn't actually the way that I want to do it. I just thought this would be the easiest way to get something working. But that might not be the case because of this, actually. So I might just take this as the cue to show some of the other ideas I had, because it would be really great to use Babashka, which that way we'll avoid that long startup time. It'll run nearly instantaneously. And what we're trying to do now can basically be done with just rewrite-clj. And yeah, actually, that's what I started doing over here. Alright, so I killed everything that was running there, and we're going to start this with Babashka now. And we'll pull in rewrite-clj. And okay, so we're not going to use this. And we're not going to use this. Or this. So we're going to take a file, which will be we'll use the same in directory, I guess. Well, it'll be different. Yeah, let's just use the resources because it's there. Oh, no, it's not, actually. Alright, so now we have our source code in the resources directory. So we would just yeah, that's not right. Wait, that's not right either. We need the absolute path, I guess. Wait. Oh, you know what? I had the name of the file wrong. There we go. Okay. So there's our parsed source code file. Let's see what we want to do with it. Well, we need to define this as implementation. And okay, first of all, we could just use the s expression function to just turn the okay, that just gives us the first form, unfortunately. So we would do something like this. Map v, which just maps the s expression function on all of the forms contained in the implementation, and then gives it to us in a vector. Apparently not. I think we would have to do something like this, actually. So let's see. We'll see what I was doing here. Let's see, what were we iterating? Yeah, we want to use the write function and iterate that on the implementation, and that's what will give us all of the forms. So, I could actually simplify this and let's just try this. Iterate to the right on iterate. Well, I think it's because of the nils. It hung up the REPL, so I just connected again. We'll redefine these. Yeah, that made it hang again. I guess I need to trash that connection and start another. Let's see if it works with the take while. Yeah, it does. So that is the problem. It was the nils at the end of the parsed code. Cool. So since the zipper data structures with all of the metadata is not of use to us, here's where we map as expression on it. And so now we just get, well, this is exactly what we want. Except that the names are not normalized the way that I thought they would be. Alright, so one thing that, so we can see that this would be a way that we could hack this together. But I was just on the way here, I was thinking about what we were trying to do, and something popped in my head. And it's the clj-kondo analysis data. So this is what's already running in our editor as our linter. But it also happens to be a static analyzer that will can provide us the analysis data. And the way that it's provided is actually in a really useful way. That gives us the locals and their usages, the keywords, arg lists, var definitions, and so I was thinking we could actually, well, maybe not just use this, but see how it's implemented, because it's implemented using rewrite-clj, but not using the zip API like we were using. It's using the node API. Borktu, the author of clj-kondo said that he prefers it, and so we get the name of the namespace. Let's see. The var definitions and the name of the var. So I'm just thinking of how we could accomplish this with rewrite-clj. Really, we just need to replace the names with our desired placeholder names. So that's here where the value is name. We can print out a zipper without the extra metadata by actually calling node. So if we map S expression, yeah, what I want to actually do is just take a look at we'll call node on the implementation. Cool. And yeah, so that's this is only the first form. So actually, let's try going to the right. All right, so this is the node of the actual source code. All right, so this says it has a tag that it's a list, and then we have define, which means we're defining a function, and what we want is the variable names. And yeah, so that's right here. And unfortunately, there's nothing here that's telling us that it's a variable name, and that's actually the problem. So it would actually be instructive, I think, to look at how clj-kondo does it. Find var sounds cool. Let's see. This is not actually I don't think this is actually the source code for the... Maybe it is. Let's see. Because, yeah, this is not creating the analysis. This is just... this is using the analysis to find the variable names. And so it seems like the it's actually part of clj-kondo itself. So here's the parser. This might be it here. We could see what happens if we just assume that any value is a variable name? No, that because it there would be no difference between this and this. Yeah, this is kind of pointing towards maybe just using clj-kondo as part of the representer. Let's maybe try that. So we could grab the binary over here. And it would be, yeah, we don't need the statically linked one. Oh, yeah, actually, we want the statically linked one because that's what runs on Alpine. Cool, yeah, that is the one that we want. And, yeah, I can actually just download this right into the repo that we're working from here. Let me just make sure that it's the same. Yeah. Oh, and I need to unzip it. Okay. Okay, now I can get rid of that, and really we just want this. Where is it? Oh, because it it pasted it back in there. Alright, so we have the clj-kondo binary that is compatible with Alpine. Excellent. Let's try running it to get the analysis data on a solution. Alright, so this is what this is piping it to jet to pre-print it. But we really just want to run this. And, oh, you know, I need to... This needs to go in the Linux side. I'll copy the path of this. And I'll just go maybe there's not supposed to be quotes. Now I'm confused. You know, that's probably not how it knows how to find the Windows file system. So instead, alright, I will just do it this way. I'll just download the release into WSL. Alright, and let's see, we need to unzip it with, do we just have unzip? Cool. Okay, so we have clj-kondo now. All right, so now we'll see if we can run this. And we actually want to skip the linting process. That was one of the options, but for now we'll just try it like this. And okay, we want it's in resources. clj. Let's see what happened. Oh, because it's not on the path, so we just need to. All right, cool. So this is our analysis. And yeah, I don't know. I'm not sure how useful this will be. It's a way that we could quickly get information about the code. But it's not going to help us out the way that I thought it would. So interesting. So this is turning out to be a little bit more involved than I thought. But okay, how does clj-kondo identify which strings are variable names? The Node API might actually do that. The Node API of rewrite-clj. So let's check that out. Okay, so the Node API has dedicated nodes for, well, there's comma nodes, there's comment nodes, and there's predicates to find out if a node is a comment function node. Okay, that represents an anonymous function. Inner integer. Okay, they're all listed right here. So, and all right, so we have var node. But the name of the argument is not a variable. This would be like arities. Oops. Function node. So the yeah, this is interesting. So the function argument names are in a vector right after the name of the function, and we might actually have to we might have to actually do that in order to determine what the names are. Let's check out the clj-kondo source. And yeah, I believe that that this is the right place to be looking. So these are the different types of nodes, okay. Protocols, quote. Now what is a token? A token node looks like it could be anything. Okay, we're dealing with different kinds of white space, and now we're dealing with keywords and strings, metadata, what we're looking for is to see how this identifies when we are looking at a function definition. Interesting. Let's see. So let's see if it's in the utilities. Token. Let's see if it's in the vector nodes. You know, let's see. So if this is a node for a function, yeah, I think this is it. So this walks a function and creates an expand function form. Interesting. Oh, what just happened? We could actually just look at that in here. So this would be the function node. Yeah, you know, that doesn't even seem... That's for an anonymous function, but... Okay, so that's the, well, that's the defen. I think maybe we just wanted to go right again. No, then that makes us fall off the edge. We do need to go down, and then we need to go right. And yeah, so now we're defining the twofer function with the value twofer. So if we go right again, now I want to actually I think I can use cavalry refactor to turn this into a refactor. Yeah, we want thread last all. Cool. So that's that. Now we can just go right again. And yeah, so here's the vector. It's tagged with list. And instead of printing out the node momentarily, I just want to see the form itself. And okay, so interesting. So that is the what's it called? The nullarity of the function, because yeah, that's interesting. And that does not contain the name. It doesn't contain the argument name. That would be in the next one. So if we went right again, yeah, this is the one. If we examine this node, yeah, so it's tagged with vector. All right. We might have to actually do this ourselves. Except I still haven't actually witnessed how clj-kondo does it. It tags it as a function. But see, that's just for an anonymous function. And so you know what I'm talking about. Let's go back into the analysis. And yeah, let's see what's in here actually. The namespace graph. That sounds interesting. Yeah, this is just a it's just a utility file to visualize your source code, which is cool. So the arg lists what we could do actually is just search the repo for that. Let's see. Huh, interesting. So it's not extract arity info. That sounds promising. And oh, yeah, somehow I found the analyzer. Okay, cool. So this is the excellent. This is the clj-kondo analyzer. If we're lucky, this will just have a function that we can use. So we have analyze children. All right, so these are the ones that might be, okay, function arity. We have analyze arity, which takes a form. I think this is already expecting to be passed a vector of function arguments. Yeah, so this is what this is what does the magic here. Analyze function body. Yeah, okay. Just seeing how involved this is actually is making me very grateful that I thought to look at this, because I'm realizing how this is actually necessary, because we don't know how the student defined the function. There's many different ways to define a function. You know, I was just brainstorming how we could do it. We could just search through the source code for the defin form to define a function, but there's no rule that says that a solution needs to even have the defin. The student could solve the exercise without ever defining a function at all. It could just be inlined. And so we would have had to come up with ways to handle all of those edge cases. Now, I actually want to look at one of the other representers to see how... I don't know if I've actually done that yet. So let's look at the one that it was for F sharp, right? I thought I had that open already somewhere, but oops. All right, let's see how this works. You know, it actually might be better to do like the JavaScript one. Yeah, it's Exercism representers. Okay, it is an SRC. Oh, that's the project file. All right, so now we're what I'm interested in is to see what this is doing to identify what the variable names are that are to be normalized. And yeah, this is not the where is the actual, is it in here? No, that's so that removes the imports. That's cool. Normalize identifiers. All right. You know, it could be that the parsing library that that he's using is doing a lot of the work here. Let's see. Placeholders to identifiers. Yeah, that's fine. Because we have this tree mapping. It could be that we're not going to actually be able to learn much with this. But that's okay because I was actually just curious. And so that's the function to normalize the identifiers, but how does it know what the identifiers are that need to be normalized is the question. Let's see what visitor does. This is a lot more complicated than I had in mind. Okay, wow. I think that satisfied my curiosity, actually. So let's say we are given a function. We need to study clj-kondo a bunch now. Like, well, first of all, how do we find the function in the source code? Analyze locals sounds kind of cool. That's for keywords. Let's see. Namespace. Huh. You know, actually, this might actually be the best way to do it, is to actually use clj-kondo to just extract the names. That would work. Okay, so wow. So we have our program, the representer, run this, and we just extract the key. Let's see what it would be. Names. It's not namespace definitions. Fixed arities. Name row. Name twofer defined by var usages. Name stir. You know, actually, I think we need to include additional data. Yeah, we want arglists stir. Yeah, alright. There we go. So we just need to set arglists to true. And now I'm not even seeing it in there. Maybe locals is what we want? I still don't see it in there. It says this is described below, so let's check this out. That's what we want, arglist stir, but how do we get it? That's, Okay, it looks like I didn't do wait a minute, let's see. Yeah, I am doing it right. 1, 2, 3, return arg lists. Yeah, we have arg lists. We want the one that's arg lists stir or whatever. Maybe that's what we need to put in the thing. No, that's still the same thing. You know what? I wasn't doing this right. Okay, that makes sense, I guess. We need to provide analysis with the map. Okay. So yeah, instead of just setting analysis to true, we can provide it with a map, which is still truthy with these options. All right, now now we get something different. All right, and yeah, arg list strings, and so we would just extract that, and that's how we get name, which is what we know how to know. How we know which names to normalize. And it's also in local usages. Also contains name, probably because if we look at the code that we are parsing, it contains name in the arity, and also so it's an arity string, and it's also a local. So either one would work. Okay, cool. So what we can do now, this is the one that is running locally, but we need the one. Okay, this is the WSL one, which has the clj-kondo binary. And what we're going to need to do is, well, run it. And so we'll pull in clojure.java.shell as shell. Whoops. Oh, this isn't connected, so let's connect. Whoops. And let's see, we need to, yeah, with Babashka. No, actually, what we want to do is not use this. Oh, we are connected, so let's pull in rewrite-clj. Yeah, see, this is already a mess. Let's start this over. Actually, I think there was one that I had going over here. Oh, yeah, it's not there because it's in the other one. Yeah, this right here. I'll just copy this and paste that here. Now I'll reconnect to the REPL. Alright, so now let's pull in rewrite-clj. We will zip up our source code. And, alright, so that is the list that contains our variable names. Okay, so now what we need to do, now actually we could have this done already by the run script. It will have already ran clj-kondo and saved it in a file that we'll call something like analysis data. But, we could actually do it here. Let's do, yeah, I think. And it's, Alright, so now we have clojure.shell. So we could actually just shell out to clj-kondo. And actually run something like that. And let's see, these all need to be contained. Let's see, so now, since we need to pass this entire map, I think that'll work. I don't know, this seems kind of sketchy. Let's see. Yeah, what does it think that's the name of a file? That's, I think that's getting messed up somehow. Let's see. Let's look at the documentation for I think we'll have to look at the Babashka process. I think we need to supply the options map, okay, separately. That might be how it works. So we contain the commands within a quoted vector. So that would be these. And then the map will be passed as the second argument. Alright, let's see if this works. It's trying to cast an object to a string. Why would that be? We might actually have to look at how clojure.java.shell works. So let's check that out. Yeah, it looks like this actually doesn't use that scheme with the vector. It's just passed as strings. But then what if we need to include an options map? Is it... yeah, it looks like that should be fine. That's how we would have environment variables. What are the in and... Oh, okay, that's encoding. Let's see what this question was. It looked relevant. Like how to use piping. It seems like it should be fine just if it's one string. Let's see. So the batch process would definitely work. But the question is there a way that we can do it using just plain old regular sh? So it's not going to be like this, but maybe if we put this entire thing in quotes, that might have worked. Okay, cool. Wow. Okay. So we'll do that, and then we need to take just the out key. And then define this as analysis. And all right, so then we actually just want we want the map. We want it as a map, not if I remember right, there's actually a way to do that. All right, I guess what I'll do is just we can just do in read string. Why can't it find clojure.shell? That's weird. That's weird. All right, well, it still worked. So it looks like we just want this is nice how it formats it all nicely. Locals, local usages. Where are the arities? we're looking for name. Ah, there it is. It's an arglist stirs of fixed arities under var definitions. Okay. Okay, so we just want those two keys from analysis. So yeah, actually we'll store the relevant keys in variables here. So the first one was var definitions. And I think it's just like this. Var of analysis. Then we got nil. So let's see. Var definitions. Okay, it's within the analysis key. And I'm just going to go ahead and do that here. Cool. So now we have the var definitions. And we want locals. Do we want to use locals or local usages? Is that what is the difference? Okay. It could be that's all we need. But to test this, let's see, we're going to... I'm glad I thought of this, because this is really important. I need to put together some kind of corpus of solutions that we can use, well, as a test corpus for what I'm doing right now. Because right now all we're finding is that that it will work for just this one tiny example. So we could, well, for example solutions, we could just look no further than the Exercism repo. And yeah, we'll just do this on the web because there is a lot going on there. What we want to do is find a nice complicated exercise. What's one that's really annoying? Go counting. Yeah, see, here's a nice juicy solution file. Let's just copy that URL here and just dump it right in the thing. And we'll put it in resources. And yeah, so now we can try it with that. Alright, so now we have this long list of var definitions. And so this is a sequence of analysis maps for each one of the forms contained in the solution. So yeah, already this is a much more honest sample of what we might be dealing with. And it could be that locals is enough. Let's see if we can determine that. That would be great. So let's see what the locals are. So here's the... Oh, yeah, cool. XS. That is indeed a variable name. Then X. Yep, that's right here. And then Y. Yeah, right there. Pred. Wow, this is great. So, oh yeah, pred is here. We're in the next... Oh, interesting. So let's see. This is... This has a map for each row, it looks like. Stones. and then we have an X and a Y. And we have J, which is in this anonymous function here. See, if I would have tried to write something myself, I would have duplicated so much of this work. But the thing is I wouldn't have even thought of that. I would not have thought to look for things like this, which that's a common thing to use, an anonymous function inlined in your code, but it contains variables which would need to be normalized. I think this is exactly what we want for retrieving the list of locals. And all right, so then to get this list, we would do we're going to map name on locals. Ah, cool. That was exactly what I wanted. Cool. So then we have a list of symbol names that need to be normalized. Now, we might have to do something other than just do a find replace for these names. The problem is that sometimes people choose names that shadow other names. Like name. And then what if they also used that in the file? Name is the name of a function called name. So I think what I'm saying makes perfect sense, but just so here we have a name, which would be replaced with a placeholder name. But let's just say that somewhere in this code they wanted to use the name function. Like let's say they had a keyword called myKey. And let's say they wanted that converted into a string. In this case, the name would get clobbered, and that would destroy the solution. We could consider that to be a rare edge case, but no. Luckily, the var definitions and the locals map also contains positional data for everything. So var definitions contains a much more, well, human readable list of where all of the names are. I don't know if that will help us in the program or not. But you know, this also doesn't contain the J and all of those, does it? Because they're not var definitions, they are arities. But yeah, because they're arities of anonymous functions. So what we're going to need to do is have an editing phase occur during the parsing. So this will be done by rewrite-clj, and we're going to edit the nodes in order to normalize the names. And our edit strategy will make use of this list here. So let's see how that would look. Alright, so that parsed our source code. And, alright. So then we're going to consult the locals map. And we'll say, just give me the first one for now. Alright, so there's the namespace declaration. Now let's go to the right. And here's the first, where the first normalization is going to take place. So let's look at the entire node. And here it is where we have the vector containing xs. This doesn't actually, it doesn't have the positional data, which is, yeah, this normalization of the names is actually a lot harder than I think would be obvious to most people. Let's look at the JavaScript one. Okay, so we're using AST parser. I wonder if, because our analysis file has the positional data, so we know that the XS is on column 20, row 3. So we could just, it seems kind of cheesy, but that's all we need to do our replacements. Oh, there's not really let's see if rewrite-clj has any cool tricks that yeah, so there's not really, I don't see anything that deals with replacements using positional data. Find last by position. Find tag by position. This might be what we need. Let's see. So what is the position? Returns the ones-based row call of the start of the current node. That's to get the position. But let's say we want to edit a node at a certain position. How do we find out which node that is? I guess that would be that find tag at position. Let's read about position tracking. So we use this track position true as an option when we create our zipper. Okay, yeah, I think this will work. So we'll add this options map to what we've got here. That's where it goes, right? And wow. So now we have the positions. Wait, oh no, that was never mind. That's I think we need to see what the auto-resolved means, because that sounded important. What is find last by position? It returns the zloc located to the last node spanning position, whatever you decide, that satisfies a predicate last node spanning position. Yeah, I guess that isn't complicated. And I think that is what we want, as opposed to find tag by position. Okay, so yeah, it could be that what we're looking for is not a tag. So let's start to walk through this slowly. So we have this list of, well, we get the first local, and we want to find XS, which is at 23. So, and XS is, let's just use the last one because, and as far as the predicate, do we have to even supply a predicate? That might have been optional. Cool, yeah, so So we're going to find last by position and of impl, and I guess we supply a vector, which would be 23, like that. It seems like, oh, it did something. All right, so then just show me the thing. That's interesting. It returned a white space node? That seems strange. It doesn't seem like that's what we want. It could be that I think I might have switched the row and the column. That might be the problem. So this should actually be 320, maybe? Aha! That was a good thought. Cool. So we can see what needs to happen. We're going to go one by one through the sequence of locals and change them by, okay, so that would happen through some node editing. It looks like that would work. Edit node, sub-edit node. Might be as an isolated subtree. You know, actually, I don't think that's what we want. I think I could make it work just with edit node, which just takes a node and a function, a loc and a function. So how do we find the okay. So this already returns the loc that needs to be edited. So we'll edit that node, and all right. By changing the value. Yeah, so our function will be something like this. This will be an anonymous function that will associate the value key, and we would be changing it to, well, it would just be placeholder 1. Or something like that. So if we call this, and well, then we would actually need to see if we can get the S expression back. I don't know why this didn't work before. Oh. Okay, that's interesting. Yeah, so for some reason, it has not edited it like it should have. This we might be able to figure out by looking at some of the examples. It could be we need to use that version of a source. Let's try that. Let's see. A keyword cannot be cast to a number. All right, let's consult the user guide for some examples of editing nodes. So where is the editing here? Here we're just using z assoc, which why is that just taking 2 arguments there? Yeah, okay. Yeah, it's because it's a pipeline. It's using the thread first macro here. Yeah, that makes sense. So, except it's using the 1 key. When shouldn't that actually be? It's because it's doing that on a vector. Okay, so here, this one is more like what we're trying to do. All right, let's try. Let's see. Let's try not editing it. In fact, that might be the problem, is that I think I'm editing it with this function, but actually, no, that's not what we want. Okay. We just want this, not this. Impl. It's trying to pass a keyword to a number, which, why, huh, interesting. Why did it work like that, but not? Huh. What is with that? Huh, so this is weird. Why, yeah, we want this here, not impl. Yeah, so now I don't know why that wouldn't work. Why is it trying to use a keyword as a number? We need to try to understand better why, what is this returning? And this data structure is just too unwieldy. Yeah, give us just the node. What just happened? Oh, wow. We can confirm that the example works. And here's one that uses a map. So let's say we have this, and we'll just call this test loc. All right, now let's just see what we'll look at just the node itself. And yeah, let's see what it has us do. We're just associating and okay. I think I just got it. The key is B. But we just want to see, yeah, so it shouldn't say value. It should say the key of whatever this thing is. So here we're looking for B, which is just the value of the thing before it. All right. So let's say we find this, and you know, here maybe it actually would be useful to see the whole thing so that we can see what the parent is. But no, see, this is just way too huge. So yeah, instead, let's see, we'll yeah, show me just the node. And we want to see what the next one up is, actually. Because right now we can't, we have no idea what the key is. So, see, we don't actually want to go up, do we? We want to go left. No. I think it's doing something. Yeah, okay. Alright, so yeah, that gives us the entire node. vector, not a map. All right. So to modify a vector, well, actually, that's the other example, the one right here. Now, let's see, I suppose that means that we're going to have to find the index of the thing that we're looking for. That's a little bit annoying. Is there a function that does that, maybe? Let's see. Because this happens to be just a single element vector. But if it wasn't, we would need to know exactly which one to modify. And actually, I believe that we now have access to the index of function. But, I don't know if that even applies here. Let's see. Here's where we might need to use like find value. That's not gonna actually help us to find out which position of the vector it is. What is replace? yeah, how do we get the position in the vector? We need to know the index that we need to replace. I mean, we could try all of them. My head is starting to spin, but I feel like I've gotten somewhere. It's just probably time for me to stop. What I'm thinking, this seems silly to have to do this, but we would have to, I can't think of any other way other than to find the right element in the vector in order to get the index. So at the time that we call this, we know that we're looking for XS. It takes a long time to execute these. Alright, so this case is easy because it's just one element. But I guess what we're going to have to do, well, we could just take this and call index of on it, and well, it's going to have to be symbol XS. Cool, and that gives us the index. All right. And then we can use the result of that does it need to be no, it doesn't. Cool. And then, yeah, then we would call this. Yeah, so I'm a little fuzzy on. All right, so what function is going to be calling this, and then how do we know? Because we're going to have to stop. You know, that's fine. And then we just know that instead of value, it's going to be 0. Index out of bounds, that's weird. Maybe we need to go up. I guess that was it. Okay, then let's do that. All right, yeah, because we navigated to the last node, which landed us inside the vector. Interesting. And that's why we needed to go back up in order to analyze the vector. That's weird. Except we can see that's what we did here. Yeah, okay, so yeah, actually that was just silly of me, I think. So cool, I think all of the pieces are in place now. I'm just so exhausted that I don't even know what I'm doing. But, oh, cool. So we just normalized that the name inside that vector as placeholder 1. Yay! Then all we need to do is just iterate through the entire list of locals and apply all of those. So, all right. This stream has been almost 5 hours, and I'm gonna take a break here, and you know, before I break, should I actually do a little brain dump and try to make an issue? Or should I just take comfort in the fact that we could review the video to find out what I need to do? Do I feel like making an issue? I should probably at least state what I'm trying to do, and at this point I don't even know if I remember. We're trying to normalize normalization. Alright, got it. Okay, so we'll make an issue that, what are we trying to do here? Apply what did I want to see what the F# one called it, because I forgot. Oh, look at that. That's a bad link there. There was another page that it was on the Exercism site. Ah, yeah, this was it, I think. Identifiers, that's what, that was the word that I needed. We'll just say normalize cool. So that's what we're trying to do. And alright. This is just going to be a little brain dump to conclude the today's work. So we experimented using rewrite-clj to apply normalizations by editing the solution's parse tree. Alright, now the thing with clj-kondo is very important because that's how we find the names to be normalized. we use the analysis data generated by clj-kondo. And I'll actually paste the function that does that so that we know. All right. Yeah, I'm going to want to include this whole thing. And var definitions and local. Do we need var? Let's see, which one did we end up using? Not var definitions, just locals. So that's, can get rid of that. If I get rid of this, and it would actually be simpler to just make that one less thing, maybe. But whatever. This is fine. Okay, and this is a closure code block. And you know, I'm going to format this better. You know, actually, this. Yeah, this is awful. Wow. Yeah, this is totally gross. Let's make a let block here, and we'll call the command something. It'll be we'll put that in a vector. This sequence of strings here. Okay, then, okay, for shell, we're going to do apply, right? Apply the shell function to the command. Alright, now isn't that much better? Except this needs to go here. And let's see if it still works. And looks like it does. Cool. Then, actually, yeah, since we really just need the the locals, we can actually get rid of the arg lists. And yeah. So that is much better. Let's see if it still works. Yep, seems like that's fine. All right. Cool. This should actually almost be a draft PR, come to think of it. Because, yeah, for this to actually have its whole meaning, it would need to have the context of the whole file, and that would be a PR. But I'm actually just trying to describe it a little bit. That nuances of the code, I guess they're not. It's just to give the idea. And okay, so then this would return, well, a bunch of, yeah, I'll write that here. So then, yeah, then we would we really do just want the locals. So let's just let's just put and then we'll call this identifiers. Get rid of this. Except no. Yeah. And then say we wanted to just get the names. There they are. Cool. That's good because that abstracts away the details of how we're getting the identifiers, which it's nice to put out of the mind just a little bit. But then every time that I use, where did we? Oh, okay. I copied this, right? Okay, this returns a sequence of maps containing the identifier each containing the identifier name row and column. Alright, so then we have to turn on position tracking. That's important. To find these positions in the parse tree, we need to enable position tracking. When creating the zipper. Cool. All right. Okay. In this example, the first name to be replaced happens to be, this is going to be code, so, and then symbol XS. And it's at position, what was it? 320. But this, okay. This was the part that was kind of tricky because we need to find out actually which position in the vector we need to be editing. So we have to do this little index of trick. Okay. To find it would be cool if it like said that in the thing. Like, oh, and by the way, it's it's this index in the vector has the ID of 1. That's okay. That's actually just that's cool actually. Scope and call and row. No, no such luck. Okay. So this is also going to be different depending on what kind of data structure contains the name. Okay, so I'll say as a single element in a vector. So yeah, that's you know, this could be easier. We could just create a new we could just find out what it is and then create a similar node. Okay. Oh, interesting. So let's see. If we, because yeah, we shouldn't have to care what kind of data structure it is in. We should just be able to replace the node. So if we, okay, what is yeah, just show me this. Show me less than that, actually. How about, actually, it doesn't matter. Let's just call the function. It's how do we find out what type of node it is? Node interrogation. That actually I guess we might have to actually just test to see This is taking forever. My editor is just hung up on this. Might need to refresh the project. Let's see. So. Yeah, see the problem here is that it's going to land us inside a node, so I guess I don't know if we're always going to have to go up, but I guess we'll find out. What if we tried interrogating that? Alright, so here, this would tell us that it's a vector, but yeah, that we don't care about that. We just want to find out what that thing is. What is it? Like what kind of node is it? It's a value. Is that is it a symbol node? Or is it a string node? I think it's a string node. Wait, no. It is a symbol. Right? Let's see. Is it really going this slow? What is it called? Symbol node, like that? Apparently not. Let's see. Wait a minute. That should work. What's did I spell it wrong? I'm gonna trash this REPL because I think something just got weird. How about what's going on? Okay, here we have that. taking so long? There must be like some, like a huge, it's probably like all of the, this is a 32,000 line REPL output. That's probably what's making it take so long. And that's interesting. Why would maybe it's not check the Babashka book. It's clojure.java.shell. Cool. Cool. We'll save that. Now, symbol node. Why is it not finding it? Let's see. Oh, you know why? Because it's not in the zip API. It's in the node API. So we need I guess we'll call that N. Cool. And we haven't loaded the implementation yet. And now we're waiting to see if this returns true or false. I think and it's false. Interesting. So that must be what a it must be a string node. It's a token node. What is a token node? So how do we know printable only? What does that mean? Inner. Huh, that's interesting. An inner node is a node that can have children. I would have thought that it would mean a node that can have that can be a child. Then what would outer? Is there also an outer? LMN? No, there is not. Unless it is tag. Does it have a tag? It's an unknown. Huh. Does that matter? Let's see. Set node. Let's take a look at the editing functions. And actually there was a replace. Let's see if that works. This might allow us to simplify this. And let's say we just wanted to replace it with, well, what do we... Oh, okay. So it's going to try to coerce it to a node. So yeah, maybe we can just have this be this string, be item. Yeah, let's try it. I think that might be good. Now let's just print the node itself. Actually, yeah. Yeah, I'm gonna have to get rid of that file because I think that's what's clogging up the whole thing. VS Code chokes on really long files sometimes. If this works, that means we don't have to do that business with finding the index every time. I think I'm still waiting for this to... Oh, there it goes. Okay, interesting. So... it created a node called lines. That might be a problem. Let's try... It looks like it works. Okay, so it happened to coerce it because all I did was give it a string. So it coerced it into that. And you know, that's probably fine. If we call s expression, and it gives us a vector with the right thing in it. So I think that's fine. All right. All right. So yeah, then we don't need that. We don't have to search for the thing. We don't need to do that. All right, now we don't care about the data structure or where it is. And You know what? There's actually each one has an ID, so we can actually number the placeholders according to the ID. That's how we'll keep track of that. So yeah, there's the implementation, 320. Cool. Sequence of maps, each contains the identifier name, row, and column. An integer ID is also given I was thinking, like, what if it has repeated names? Then we wouldn't want to give it a new number. We should have them just go in order. So yeah, never mind about the integer ID, but who knows? Maybe we'll use it. With a string value of placeholder 1, and yeah, that's a real string. Alright, so I think that's pretty much it. Almost up to 6 hours, wow. So yeah, that's as far as I actually got. But that's good. Alright, so yeah, so I'll just sum this up by saying the entire solution can be normalized. Likewise, by iterating through of identifiers. And yeah, I think repeated names will have the same placeholder numbers. Did I spell that wrong? Identifiers. Cool. And yeah, that's using the magic of clj-kondo to locate those names, because wow, I never would have been able to get that right. And since the F# one uses that special parsing, it's like a special library for parsing F# code, I think. So that probably made that fairly straightforward. So I'll submit this issue. I want to put that note there, actually, and actually link to the analysis. Yeah, this is the actual analyzer. This is amazing. Yeah, okay. Note. Accurately determining precisely which names refer to locals. Is that good enough to describe refer to which names refer to identifiers which should be normalized as opposed to function names. Which would break the solution if changed. Is no small task due to the several ways that functions can be defined in Clojure. To the various ways okay. To appreciate the value provided by the and this will just be a link. Cool. Cool. All right. Wow. I think that wraps it up. We'll be able to continue this next time by simply writing our iterator function and then doing the other normalizations sometime after I get some sleep. So, roll outro music. Roll outro music, please. My sound is muted. Haha, what a dirty trick. Oh yeah, we have to try that again. Okay. If you'd like to support the creation of future streams by helping me continue to afford this office studio space, check me out on Patreon at patreon.com/BobbyCodes. That's BOBBI codes. And see you next time. Oh wow, this was fun. Oh, that was so much fun. That is great.